So we understand what is sigma means, standard deviation, okay? And what is sigma squared means. The square of the standard deviation is called as a variance. The observed variation, what you have written as data, because in the measure phase, we collect the data. And this data that is collected, the data that we have observed has a variation, and that variation is because of two things. It is because the process itself has a variation and the measurement has also got a variation. For example, let's say a water bottle, you are filling 1 liter water bottle, okay? 1 liter is 1000 ml. Will it be exactly 1000 ml? No. The start and stop of the machine might have a small variation, maybe plus or minus 5 ml. The process itself might have a variation. But what you are measuring as the water volume might also have, the measuring device might also show the variation. Okay, this is a quiz question. Do you want this to be as high or as less as possible? Yes, as low as possible. Correct. So this observed variation is equal to the real process variation plus the variation due to measurement system. And we will focus on this, and we want it to be as low as possible. Okay. Now this is, now when we come to the transactional process, I want to just highlight, because in many of the books, the transactional process measurement variations are not given. I wanted to give a piece of this. If you really want to classify the different things that influence the measurement, okay, the customer, the process rules, the environment, the work methods, the rewards and recognitions, the cleanliness of the workplace, the noise and other distractions, lighting, room temperature, proper equipment. In work methods, ease of data entry, training given, work time, SOPs, the technique of the appraiser, understanding of written process rules, understanding of unwritten process rules, clarity of requirement, congruence of requirement. Now, I'm not going to explain this, but this is a homework to you to think over and ponder. So many things that can influence in the transactional processes, our measurement. In operation process, it's very straightforward. The tool can cause the variation. Because of the tool, the materials, the environment, the work methods, the mechanical instability, the wear and tear, the electrical instability in some cases, maybe if it is a algorithmic instability, and so on and so forth. Okay, humidity, cleanliness, vibration, line voltage. There are so many things that can cause the variation. Okay, so I leave these two as a homework for you to ponder and think over, see what all can cause those variations that ultimately result in the variation in the measurement. So this variation cannot be complete. So to understand this variation, we have to understand normal distribution. Normal distribution is the simplest form of distribution. It's a bell-shaped curve. Whenever you measure things, for example, I'll tell you how to plot a normal distribution in a very simplistic way. If it is in a class of 100 students, you measure the height of all the students, okay, and you plot them, okay. The height which are say 4.5 feet to 5 feet, how many people are there? 5 to 5.25 feet, how many people are there? 5.25 and 5.5 feet, how many people are there? And 5.25 and 6, how many people are there? And so on and so forth, okay? Or if there are different weights, 40 to 45 kgs, how many people are there? If you measure the weight of 100 people, right? 45 to 50, how many people are there? 50 to 55, how many people are there? And so on and so forth. And if you plot that frequency, it's called as a frequency of occurrence, right? That frequency with respect to that parameter, which is the weight, then it forms a distribution. Generally, it has got a bell shape, which means major reading is towards a particular interval value. Suppose if I ask you this question, what is the average age of Japanese people? Give a range. Okay, some range you give. So similarly, when you classify this thing under different ranges, then you can form a distribution. This is called as a curve, a graph. This is in the inverted bell shape. More is towards the center and less is towards the end. This is called normal distribution. Okay. So if you see here, most of the things are towards 70. And people who are more than 100 kgs are very less. There is someone who is say 92 or 93 kgs. And there are people who are less than 50 kgs, very less. Nobody is 40 kgs. But this is observed process variation with the measurement error. But if there are no measurement error, it can be closer. Because of the measurement error, it is showing a wider range.